Hello everyone, I hope you're doing well. In this video, we're going to talk about forces of attraction. Before we jump into the forces themselves, we want to take a look at the difference between these two prefixes. All right, it's easy to mix these up, so you want to have a good understanding of intra versus inter. Okay, the key for intra is you're dealing with one thing, one object. Okay, in the example here, we have intramolecular forces. That is the forces within a single molecule. These intramolecular forces create the attraction between the atoms of a single molecule. Okay, and we're going to talk more about this as the notes continue. Right now, we just want to focus on the difference between intra and inter. Okay, so intra means within one thing. Inter means between two or more things. Okay, so intra is one thing, inter means two or more things. The example here is intermolecular forces create the attraction between different molecules. Okay, a little helpful hint for remembering these: inter has an E for everyone. Okay, you're dealing with multiple things, multiple objects. Intra has an A for alone. You're only dealing with one thing for intra. Okay, moving on to how we use these prefixes to describe forces. First up, we have intra, within a single molecule forces. Okay, intramolecular forces, these are the forces that create compounds. And you've actually already learned these. We learned them as types of bonds. So here are the 4 types of bonds that we covered for intramolecular forces, and they are listed with the strongest bond first. Okay, so the strongest intramolecular force, that's going to be metallic bonding. A little weaker is going to be ionic. Weaker still, polar covalent. And then the weakest, nonpolar covalent. All right, we're not going to focus too much on these intramolecular forces for these notes because, again, you should have already learned them. These intramolecular forces, they determine which elements will bond together. And we took a look at that with Lewis structures for bonding. We took a look at that with determining what type of compound we have. Okay, this is all about valence electrons. Why is stuff going to react? Stuff's going to react to fill its octet. All right, and since these intramolecular forces determine how elements combine, these forces are responsible for determining an element's chemical properties. Okay, this is how they behave chemically. Intermolecular forces are the forces between different molecules. All right, and a key thing to remember is your intermolecular forces will always be weaker than the bonding or intramolecular forces. All right, intermolecular forces, they're attraction between molecules, and we have a list here, and these are also listed in decreasing bond strength. So the strongest type of intermolecular force is hydrogen bonding. Next up, we have dipole-dipole forces. And finally, we have dispersion forces, also known as London dispersion forces, also known as van der Waals forces. All right, we're going to talk about each of these individually in the coming slides. So here we go. Dispersion forces have another name. They're also called London dispersion forces. The nice thing about these is they're pretty similar. They also have a third name. They also go by van der Waals forces. All right, you need to know all 3 refer to the same thing. These are the weakest type of intermolecular forces. They are weak and they are temporary. These types of forces are caused by shifts in electron density. All right, and hopefully this will make more sense when we look at an image on the next slide. Basically what happens is when 2 molecules get near each other, the electron cloud of one molecule pushes or repels away the electron cloud of the other molecule. So here, this is like a before image. The next slide will be the after image. And what we want to notice here is the arrangement of electrons. Okay, these are pretty evenly spaced out throughout the molecule. Okay, same thing over here on the right side. All of these negative electrons are pretty evenly spaced out. All right, but if we bring these molecules closer together, notice what happens. Since the electrons all have the same charge, they want to repel each other. Okay, so we took the molecule on the right and we moved it closer to the one on the left, and these negative charges are going to push on each other and try to get as far away as possible. Again, this is temporary. This is caused by the molecules coming near each other. All right, so these are temporary. They go away if you separate the molecules. Again, these are considered weak forces. They get stronger with more electrons. Another way to think about that is these forces get stronger as the atom gets bigger, right? Higher atomic number means you're going to have more electrons. More electrons means more charges pushing other charges away. Alrighty, these dispersion forces explain why, under normal conditions, right, that's regular life stuff, normal atmospheric conditions. Look at your halogens. Fluorine, chlorine, those are gases. Bromine is a liquid, and iodine is a solid. This is because the forces, the dispersion forces, get stronger as the atoms get bigger, right? If you look down your halogen row, fluorine's the smallest, chlorine's bigger, and so on. Okay? The strength in the bonds, or the forces between the molecules, can keep bromine a liquid and can keep iodine a solid. All right, because those forces can absorb energy, and it takes energy to go from solid to liquid and from liquid to gas. Next up, we have dipole-dipole forces. Remember, dispersion forces create temporary dipoles. Polar molecules create permanent dipoles, and that's what these are. Dipole-dipole forces are permanent dipoles. And this is an attraction between the oppositely charged regions of separate molecules. All right, so what we have here is we have a polar molecule. All right, we can assume that this element is more electronegative than the element it's paired up with. All right, that's what this is showing us. This little symbol here, this is lowercase delta. All right, you don't really need to worry about that so much. It's just showing us that we have a partial negative charge on this atom, and this one, and this one, and so on. We have a partial positive charge on these. All right, and this is due to electronegativity differences. All right, this atom here that's partially negative is much more electronegative than its friend that it paired up with. All right, it means this thing is greedier for electrons, and this thing is going to be partially negative because it's going to share the electrons unequally. This one's greedier. It's going to take the electrons more often. Alrighty, and then when we get multiple of these atoms arranged near each other, you can see that the opposite charges form bonds. All right, these are bonds that connect these molecules together. Hydrogen bonds are next. These are the strongest type, and these are just a specific type of dipole-dipole forces. Okay, these are a specific type of dipole-dipole forces. And these can only occur when we have hydrogen and one of these three elements. Okay, so you can only have hydrogen bonding with hydrogen and one of these three elements. In this class, we're going to focus most on how hydrogen bonding applies to water. Down here, we have an example of several water molecules near each other. Notice since hydrogen is much less electronegative than oxygen, hydrogen ends up with a positive charge. The oxygen is much more electronegative, so it ends up with a partial negative charge. And then when these water atoms, or molecules, when these water molecules get near each other, we can see the negative oxygens are pointing at the positive hydrogens, all right, and vice versa, because these opposite charges will attract, they will bond, and these bonds can absorb or resist energy. These hydrogen bonds explain why water is a liquid at room temperature, but similar compounds are gases. All right, water has strong hydrogen bonds, which means its melting point is much higher than other similar molecules. All right, that's it for these notes. If you got any questions, let me know. Best of luck.